In the beginning, there is silence. Not the silence of an empty room, not the hush of a midnight forest, but a silence so complete it feels as if existence itself has forgotten to breathe. Out in the void, where the sun's glow is nothing more than a faint memory, and the warmth of planets has long receded, there lingers a stillness that mocks the senses. Yet within that silence lies a secret, one that humanity has only just begun to suspect. The solar system, which we once believed mapped, measured, and understood, may still be hiding something of unimaginable scale. A world, a planet, a mystery orbiting inside our very home. The story of discovery has always been the story of anomalies, of faint whispers that do not align with the harmony we expect. For centuries, astronomers looked to the skies and found orbits behaving in ways that betrayed unseen hands. Uranus, when first observed, did not move exactly as Newton's laws predicted. Neptune was not on the star charts, and yet its presence was inferred before it was seen. A wobble in the dance of planets gave away the existence of another, and so it has been before, and perhaps so it is again. The suspicion that there may be a hidden planet is not born of fantasy, but of mathematics and gravitational truths that target our imagination like unseen tides. To stand beneath the night sky and contemplate that one of our neighbors remains unseen is to confront the limits of human perception. We can peer into galaxies billions of light years away, and yet something vast and close could be cloaked from us, waiting. The notion is not only humbling, but haunting. It forces a re-evaluation of what it means to know, to map, to measure. Could our solar system, the cradle of humanity, still hold a giant among its children, passing unseen through the cold corridors beyond Neptune? Could a massive planet wander just beyond the edge of sight, its orbit measured not in centuries, but in tens of thousands of years? The whispers of this possibility emerge not from casual speculation, but from data. Astronomers studying the Kuiper Belt, that frozen collection of worlds beyond Neptune, stretching outward like shards of forgotten creation, noticed something unusual. The orbits of some of these distant objects were not random. Instead, they clustered in strange alignments, as if an invisible shepherd guided their paths. These alignments defied coincidence. They suggested that a massive object, perhaps several times larger than Earth, was exerting its pull from the shadows. Just as Neptune revealed itself through Uranus's wobble, so too might this unseen world reveal itself through the dance of the Kuiper Belt's icy exiles. The first seeds of this suspicion were planted not in modern times, but over a century ago. Percival Lowell, an astronomer obsessed with the idea of hidden planets, believed another world, Planet X, must lurk beyond Neptune. His calculations led to decades of searching. Clyde Tombaugh, a young astronomer, working tirelessly through nights of photographic plates, finally discovered Pluto in 1930. But Pluto was too small to explain the anomalies. It was a hollow victory, a fragment of the truth mistaken for the whole. The idea of Planet X faded, dismissed as a dream of an earlier generation. Yet history has a way of circling back, of resurrecting mysteries when new evidence arises. And so it did. In the 21st century, with the discovery of Sedna, a lonely world with a bizarre elongated orbit, astronomers were once again confronted with questions that echoed Lowell's suspicions. Sedna does not belong to the familiar order of planets and dwarf planets. Its orbit stretches so far beyond Neptune's domain that it suggests an exile, a world torn by the gravity of something larger. More discoveries followed, like 2012 VP113, whose orbital path also defied the expected. Each new icy object seemed to whisper the same truth. They are not alone. Their orbits bear the scars of a massive neighbor, unseen but undeniable. Konstantin Batygin and Mike Brown, astronomers at Caltech, revisited this puzzle in 2016. Through mathematical modeling, they proposed the existence of a hidden planet, perhaps 10 times the mass of Earth, orbiting hundreds of astronomical units away. They named it, cautiously, Planet 9. Their calculations suggested that this massive world could explain the clustering of distant Kuiper belt objects. It could also account for the tilt of the solar system's plane itself, as though the sun and its children had been subtly shifted by an unseen gravitational partner. It was a revelation that reignited imaginations across the globe. Was Planet 9 not only real but already shaping the very architecture of our cosmic neighborhood? Yet disbelief remains a natural response. How could something so large evade detection in an age of powerful telescopes and infrared surveys? The answer lies in distance, in faintness, in the limits of our technology. A planet orbiting at 400 to 800 astronomical units, hundreds of times farther than Earth, would be unimaginably dim. Even a world several times Earth's size would reflect almost no sunlight from that abyss. The light it does give back is spread so thinly across the sky that it vanishes into the background of stars. It is not impossible for such a planet to remain hidden. It is, in fact, almost expected. There is also the human element to the mystery, the audacity of belief and the humility of doubt. Astronomers must tread carefully between discovery and illusion. Many anomalies in history have proven to be errors, coincidences, or artifacts of measurement. Yet to ignore the possibility is to close the door on wonder, to silence the whispers of the cosmos that call us to look deeper. Battigan and Brown's work sparked a wave of renewed searching. The Subaru telescope in Hawaii, with its wide-field hypersuprime cam, began scanning the skies for faint, moving objects. The upcoming Vera C. Rubin Observatory promises to map the heavens in unprecedented detail, possibly catching the fugitive world at last. And so the search continues, guided by mathematics, haunted by mystery. But behind the science, behind the instruments and the equations, lies the deeper question: why does the possibility of a hidden planet strike such a chord in us? It is not merely curiosity, it is existential. Humanity has always sought to impose order, to name and chart every corner of its world, then its solar system, then its galaxy. To discover a planet in our own backyard that we somehow missed is to confront the limits of our knowledge. It is to admit that the story of the solar system is still unfinished, that we are still children looking into the night sky without understanding all the players in the cosmic play. And there is more than scientific curiosity at stake. If Planet 9 exists, it may not only shape orbits, but also histories. Some astronomers speculate that a massive planet in the outer solar system could have perturbed comets, sending them hurtling inward toward Earth across epochs. Could such a hidden world have played a role in the bombardments that shaped Earth's surface, even in the mass extinctions that reset life's course? The idea lingers at the edges of imagination, that an unseen neighbor might be entwined with the story of life itself. The notion of a hidden planet also reawakens older fears and fascinations. Ancient myths across cultures often spoke of shadowy worlds, of hidden realms orbiting in the heavens. Babylonian astronomers imagined wandering stars that could not always be seen. The Greeks dreamed of invisible worlds beyond the known. Today, those myths find echoes in the data of modern astronomy. What they once envisioned as gods or omens, we now approach through gravitational equations and telescope surveys. Yet the essence remains the same. The cosmos may still hold more than we see. As the 21st century unfolds, the mystery of the hidden planet becomes a mirror, reflecting both the cosmos and ourselves. It reveals our relentless pursuit of truth, our refusal to accept final answers, our hunger to push the boundaries of the known. It also reveals our vulnerability, our fragility before the enormity of the universe. The solar system is not finished. It is alive with mystery, A world may still circle the sun, massive and silent, waiting for us to notice. And in that waiting, in that suspense, lies both the terror and the beauty of science. The mystery of a hidden world orbiting our sun is not merely a question of curiosity, but one of evidence of how fragile our certainties are when faced with subtle deviations written in the heavens. The solar system was once thought to be a finished map. Mercury to Neptune, with Pluto relegated to the shadows of dwarf planets. The narrative was closed, the story complete, as though human discovery had put the final punctuation on the sentence of our cosmic neighborhood. Yet science resists endings. Data continues to whisper, anomalies linger like ghosts in the equations, and the gravitational scars on distant bodies remind us that reality is never as simple as we desire. The seeds of this suspicion stretch back to the very birth of planetary science. In the 19th century, astronomers noticed that Uranus was wandering. Its orbit did not perfectly align with Newtonian predictions. The irregularities were small, subtle, but persistent. From those discrepancies, French mathematician Urbain Le Verrier and British astronomer John Couch Adams, working independently, calculated the existence of an unseen planet tugging at Uranus. Their predictions led to the discovery of Neptune in 1846. It was a triumph of mathematics, a testament to human reasoning reaching beyond sight. Yet, in the wake of this triumph, new irregularities remained, this time in Neptune's orbit itself. And from those ripples in the cosmic pond, the idea of yet another hidden planet took hold. The elusive Planet X. Percival Lowell, the wealthy American astronomer, became the most ardent champion of this quest. At his observatory in Flagstaff, Arizona, Lowell poured his fortune and his obsession into the search. He believed in canals on Mars, in alien civilizations, and most of all in Planet X, a giant body lurking beyond Neptune, responsible for the unexplained motions of Uranus and Neptune. Night after night, Lowell scanned the sky, convinced the hidden world was within reach. But his efforts ended in frustration and death in 1916, with the planet still unseen. His legacy, however, endured. Years later, his observatory continued the search, leading to the discovery of Pluto by Clyde Tombaugh in 1930. At first, Pluto was hailed as the long-sought Planet X, but Pluto's mass was far too small to account for the observed anomalies. The celebration turned hollow, and the mystery deepened. For much of the 20th century, Planet X was relegated to the margins of astronomy, a half-forgotten dream of eccentric men. But the cosmos has a way of reviving its secrets when humanity is ready. With the advent of powerful digital surveys and sensitive detectors, astronomers began to uncover worlds beyond Pluto. The Kuiper Belt, a vast disk of icy remnants from the solar system's formation. Here, among the frozen debris, Sedna emerged in 2003. Its orbit was astonishing, a stretched ellipse that carried it thousands of astronomical units from the Sun, far beyond the gravitational reach of Neptune. No known process could explain such an orbit. It seemed as though Sedna had been sculpted by an invisible hand, a massive, unseen companion whose gravity carved the outer solar system like a knife through water. More discoveries followed. Objects like 2012 VP113 displayed similar elongated paths, their perihelia clustering together in defiance of randomness. The statistical odds of such alignment without an external cause were vanishingly small. This was not chance. It was a pattern, and in patterns, astronomers hear the echoes of deeper truths. It was as if these lonely ice worlds, drifting in their vast orbits, were sending us a message. There is something else out here, something powerful enough to orchestrate their dance across millions of years. Konstantin Batygin and Mike Brown, working at Caltech, took up the puzzle. Brown was already infamous as the man who killed Pluto, having led discoveries that reclassified Pluto as a dwarf planet. Yet in 2016, he and Battigan proposed something far larger than Pluto, a planet perhaps 5 to 10 times Earth's mass, orbiting at a distance so vast that its year might last 10,000 to 20,000 Earth years. Their simulations showed that such a body could explain the clustering of distant Kuiper Belt objects. It would not only herd their orbits, but could also tilt the entire plane of the solar system by several degrees, an effect that had puzzled astronomers for decades. Suddenly, Planet 9, as they cautiously named it, was reborn not as fantasy, but as a compelling scientific hypothesis. The implications were staggering. A world of such mass and distance would not merely be a curiosity. It would redefine our understanding of the solar system. For centuries, the architecture of our neighborhood seemed complete, with 4 rocky worlds, 4 giants, and a debris field of dwarfs. But Planet 9 would rewrite that narrative. It would join the ranks of the great planets, a missing titan, hiding in plain sight. Its existence would mean the solar system is not a finished sculpture, but an unfinished story, with entire chapters still unwritten. Yet the prospect invites skepticism. How could humanity, with all its telescopes, spacecraft, and sky surveys, fail to notice a planet of such size? The answer lies in the tyranny of distance. At 600 or more astronomical units, the sunlight reflecting off Planet 9 would be 1,000,000 times fainter than Pluto's. Even the largest telescopes would struggle to distinguish it against the crowded backdrop of stars. Moreover, its orbital path might carry it through regions of the sky poorly surveyed or avoided altogether due to the density of the Milky Way's background light. Planet 9 could be hiding in the brightest clutter, camouflaged by the very stars we admire. Some astronomers argue that Planet 9 may not exist at all, that the observed clustering could be the result of observational bias or statistical flukes. The sky is vast, and our surveys incomplete. Perhaps we have been deceived by our own data. Yet others counter that the consistency of the alignments across independent discoveries strengthens the case. Even with the limited sample, the odds of chance remain small. Science thrives on such tension, between doubt and possibility, between skepticism and imagination. The mystery endures because it resists easy dismissal. The human reaction to this possibility reveals much about our place in the cosmos. To imagine that our solar system holds secrets still hidden evokes both fear and wonder. Fear because it suggests our knowledge is fragile, our maps incomplete. Wonder because it opens the door to discovery, to the idea that the familiar is not fully known. In an age where so much seems charted, the notion of a new planet within reach stirs the ancient thrill of exploration. Just as sailors once sought unknown continents across the oceans, astronomers now search the void beyond Neptune for a hidden world that could reshape our understanding of the sun's domain. Consider the irony. While we send probes to distant planets, rovers across Mars, and telescopes to the edge of the universe, a massive planet may still orbit unseen in our own backyard. This irony is not failure, but humility. It reminds us that discovery is not a linear march, but a dance of insight and error, of illusions dispelled and mysteries unveiled. Each discovery reframes the map, not as a finished product, but as a living canvas, perpetually unfinished. Planet 9 embodies this truth, that the universe is always larger than our imagination, and that certainty is the greatest illusion of all. The search continues. Astronomers comb through vast databases of images, hunting for faint moving dots among the stars. The Subaru telescope in Hawaii, with its wide-field camera, has become a key tool, scanning regions of the sky where Planet 9 might hide. Each observation adds constraints, narrowing the possibilities, refining the models. The Vera C. Rubin Observatory, when it begins operations, will map the heavens with a depth and breadth unmatched in history. Its surveys may finally catch the faint wanderer in motion, a slow drift across years of data that betrays its presence. If found, Planet 9 would not only validate decades of suspicion, but ignite new questions. How did it form? Where has it been? And what does its existence mean for us? Planet 9 may have shaped more than orbits. Some scientists speculate that a massive distant planet could perturb the Oort cloud, sending comets cascading inward across epochs. Such perturbations may have influenced Earth's history, triggering episodes of bombardment that altered the trajectory of life itself. If so, the hidden world is not merely a distant neighbor, but a silent participant in the story of Earth, perhaps even in the rise and fall of species. Its gravity could be entwined with our own evolution, a cosmic puppeteer whose strings reach across billions of miles. And yet, perhaps the most profound impact is philosophical. The possibility of a hidden planet reminds us that knowledge is provisional, that maps are temporary, that certainty is fragile. It rekindles the humility that science demands, to admit what we do not know, to search where we have not looked, to remain open to the universe's secrets. It also rekindles awe, the awe of standing beneath the stars, knowing that somewhere among them, perhaps even now, a massive planet circles the sun, indifferent to our curiosity, waiting for us to notice. The silence of space is deceptive. Within it lies motion, within motion lies pattern, and within pattern lies truth. The outer solar system whispers of something vast and unseen. Whether that whisper is illusion or revelation remains unknown. But the search itself, the relentless pursuit of the hidden, is as much the story as the planet itself. It is the story of humanity, forever chasing mysteries into the dark, forever believing that the cosmos holds more than we see, forever reaching, forever unfinished. He draws nearer, not as an object, but as an absence we can almost measure. The shock is not in seeing him. No telescope has yet caught the wandering ember. But in watching other worlds bow to an influence that should not be there, in a universe defined by order, by equations that promise the same result each time they are balanced, it is a strange and unsettling feeling when the numbers refuse to settle. The sky is a ledger kept in gravity's handwriting, and across the outer margins of the solar system that handwriting curls unpredictably, like a signature we cannot authenticate. The discovery is not a shout, it is a tremor in the floorboards, a floor we thought solid. Why is the idea terrifying? Because a planet is not a pebble you can misplace. Because our instruments have peeled back the veil on galaxies that died before Earth had oceans. And yet something several times the mass of Earth could circle our own sun and remain uncounted. That contradiction rattles the frame of modern astronomy. We know how brightness drains with distance, how sunlight thins until it is only a cold rumor in the dark. We can compute the apparent magnitude of a super-Earth at 600 astronomical units and show that it would drown inside the Milky Way's crowded star fields. We can remind ourselves that if its albedo is low, its skin is a charcoal winter that returns almost nothing to our eyes. We can blame the galactic plane, where dense star fields and dust make camouflage effortless. Those are reasonable explanations, and yet reason does not quiet the unease that something so consequential has weighted beyond our grasp, watching our overconfidence flicker. The terror deepens with time. When Uranus misbehaved, Neptune appeared within a single human generation of calculation. We projected a position, a telescope found a point of light. The ledger balanced again, but this time the problem lingers. Years pass, surveys expand, the sky is digitized in broader strokes, and still the shepherd remains a rumor with teeth. We invoke patience. The path is glacial, the motion on the sky no more than a crawl. One needs years to see a change of a few arc. Seconds, but patience is not reassurance. It is suspense stretched thin, and suspense, carried long enough, begins to taste like dread. There is a philosophical vertigo in the idea. that the solar system is incomplete. Humans derive comfort from finished lists. 8 planets, innumerable smaller worlds, all placed like pieces in a crystal museum. The suspicion that a large new piece exists scrambles the museum's labels. What else, then, is provisional? The tilt of the sun's spin axis relative to the planetary plane, could that too be a consequence of an unseen partner? The strange, synchronized arguments of perihelion among the most distant scattered objects, could that be the drumbeat of an orbiting conductor? The mind resists because the mind prefers closure. But the cosmos prefers open sets. Even the methods we trust most turn treacherous in this far dark. Infrared surveys, like those that map the sky with a heat-seeking gaze, should have lit up a mini Neptune that glows faintly with leftover formation heat. They did not. From this absence, constraints cascade. Perhaps the object lies beyond the survey's sensitivity at the time it scanned those sky regions. Perhaps its temperature is colder than we assumed. Perhaps its radius is smaller, its atmosphere thin. Or perhaps it hid in the blind spots of cadence and coverage. Science is an argument with uncertainty. It proceeds by fencing impossibilities until the remaining pasture is small enough to search blade by blade. The shock is not only observational, it curls into the heart of dynamics. Consider the clustering problem: 6 or more distant objects whose long axes point in similar directions, whose orbital planes congregate like schools of fish under the pressure of a hidden predator. The statistical weight of that alignment resists the shrug of coincidence. Computer experiments seed the outer solar system with a massive perturber and let millions of simulated years pass. Out of the numerical weather, patterns condense that match what the real sky shows. That is not proof. But in science, when maps drawn from equations rhyme with maps drawn from telescopes, the hair on the back of the neck stands up. Every proposed explanation challenges some pillar we assumed secure. If the shepherd is a planet, then where did it form? Core accretion prefers the temperate zones of the early solar nebula, where ice and dust were abundant. Did the planet grow nearer the sun and later migrate outward along gravitational highways carved by the giants? Did Jupiter and Saturn's resonant tug-of-war sling it like a stone into a wide, tilted period? Or was it captured, a rogue planet cold and homeless, bound by the sun during a close stellar encounter in the nursery cluster? Each pathway changes the origin story of the system that made us. Each pathway forces us to redraw the early choreography of giants and debris, to admit that stability was hard-won and contingent. And then there is the strangest speculation, the one that tests the edges of our imagination, that the unseen mass is not planetary at all, but a primordial black hole, a fossil from the first fractions of a second. After the Big Bang, its event horizon the size of a fruit, and its gravity the weight of several Earths. Such an object would be darkness perfected. No reflected sunlight, no thermal glow except perhaps the faintest whisper of accreting dust. It could be found, some argue, by microlensing, by waiting for a background star to brighten as the compact mass passes in front, or by watching for a ghostly rain of annihilations if dark matter clusters near its well. This is an idea that wakes old fears and new rigor. Stephen Hawking taught us that black holes can evaporate, that quantum fields stitch trembling particles along the horizon. Einstein taught us how space-time curves into wells that trap even light. To imagine such a thing in our own suburbs is to feel both poets and physicists go quiet. But the hypothesis, however exotic, is anchored in a simple, disquieting observation. We have not seen a planet that could be there. That absence invites monsters and marvels alike. Science must hold both at a distance, the romance of speculation and the discipline of data. Einstein would advise us to keep theories as simple as they can be, but not simpler than truth requires. Occam's razor prefers a planet to a black hole until the sky forces a sharper cut. What makes the whole affair feel like trespass against settled knowledge is the cumulative weight of secondary consequences. A massive, distant body should leave fingerprints everywhere, in the population of high-inclination trans-Neptunian objects, in the warp of the Kuiper Belt's outer edge, perhaps even in the statistics of long-period comets. Each implication becomes both a clue and a liability. If the fingerprints are there, the case grows. If they are not, the case thins. And the sky, generous and cruel in equal measure, offers both hints and denials. Some surveys report unusual object distributions that align with the Shepherd model. Others insist the pattern dissolves under corrected biases. The shock lives in the stalemate. When reality refuses to collapse into a definitive yes or no, the imagination oscillates, and that oscillation is a kind of fear. Our instruments are strong, but the problem is designed to exploit their weaknesses. The wanderer moves slowly, so we must wait for motion to betray it. It is faint, so we must integrate longer and deeper, risking confusion with static background. It may traverse fields dense with stars, where every pixel is a crowd. The plan, then, becomes patience made mechanical. Repeat exposures over months and years. Subtract today's sky from last season's. Let software sift the differential noise for a dot that walks instead of twinkles. The science is humbling in its simplicity and heroic in its scale. We will drag a net through the ocean of the night and count every fish twice. A hidden planet troubles not only methods but metaphors. For generations we used clockwork to describe the heavens. Later we used the language of fluid and field. But the image that best fits this moment is not a clock and not a river. It is a stage with a missing actor whose lines are already in the play. The other performers pause, glance stage left, deliver their cues to empty air. The audience knows a figure is meant to enter. When he does not, the entire scene acquires a tension that will not resolve. That tension builds meaning it does not earn and dread it does not intend. We watch the entrances again and again, listening for footsteps that are not there. The danger, to knowledge and to narrative, is hubris. We built a cathedral of certainty on 8 pillars and considered the nave complete. We forgot that the foundation stones were set in a storm. Early in our system's life, worlds migrated, resonances broke and reformed, tides of gas and pebbles shifted fortunes in an hour. If a 9th world survived that storm and took refuge in the far cold, his quiet is not our embarrassment. It is a reminder of how provisional survival can be. The shock, then, is a kind of gratitude misdelivered. We are surprised not that he exists, but that we ever believed he could not. General relativity hovers at the edge of the conversation like a stern elder. Gravity is geometry, Einstein told us, and geometry is destiny. If there is a hidden well in our outskirts, space-time itself is bent in a way we have not yet traced. Mercury's precession once betrayed the incompleteness of Newton. Perhaps the collective precession of the far diaspora will betray the incompleteness of our census. We imagine a faint curvature added to the sun's vast bowl, a ring of altered geodesics that shepherd ice into schools. There is beauty in this picture, a beauty born from consistency across scales, from the idea that the same geometry that stirs a star's light near a black hole can also incline a pebble's pilgrimage in the Kuiper dark. Stephen Hawking would warn against the seduction of untestable scenarios, and so the shock is accompanied by resolve, to test, to falsify, to search. We will measure stellar occultations by distant objects and infer shapes and densities that hint at unseen sculptors. We will refine orbital elements until subtle resonances either appear like lace or unravel like myths. We will track the solar spin and the planetary plane, and ask whether an ancient handshake with a missing partner is still inscribed in the tilt. The terror becomes a program, the vertigo a schedule. The strangest part of all is how intimate the fear feels. A new exoplanet in a distant system rarely unsettles. We classify it, file it, and move on. But a hidden world here, under the same sun that warms our oceans and our roofs, is a different kind of intrusion. It collapses the distance between the unknown and the familiar. It suggests that mystery does not live only in other galaxies or earlier epochs. It breathes behind our house, in the hedgerow we never trimmed. To admit that is to admit that exploration is not an era that ended with maps and machined lenses. It is a posture of mind, a willingness to be surprised by the yard you thought you owned. And so the shock, properly understood, is not a wound, but a widening. We discover that the solar system is larger in meaning than in miles, that our ignorance has edges we can touch, that humility is a light better than any lantern because it keeps us searching rather than staring. Somewhere, a world may move with the dignity of a slow cathedral, an orbit that writes centuries between commas. Somewhere, his shadow passes over a field of stars, and for a moment, a single point brightens and then dims, and we will call that moment proof. Until then, we live in the interval between suspicion and sight, a place science knows well, a place both fragile and fertile. This is the terror that our confidence was an aesthetic preference, not an empirical guarantee. This is the promise that the universe forgives our preferences and waits for us to correct them. The ledger will balance, or it will be rewritten. Either outcome is a kind of grace because both are honest. In the meantime, the planets turn, the comets dream, the ice remembers the hand that shaped it, and the unseen mass, planet, black hole, or empty rumor, writes its signature across a darkness that is not empty at all. It begins not with sight, but with whispers, cold data stitched from the faint motions of worlds too far away for human eyes to care about. The Kuiper Belt, once thought a simple graveyard of ice, has become a scripture. Its fragments, each a frozen body circling the sun in silence, speak in orbits that refuse to be random. Their perihelia cluster like reeds bending in the same direction beneath a hidden wind. Their inclinations tilt as though some invisible tide pulls them askew. For those who study such things, these patterns are not curiosities. They are messages, and the message is clear. Something vast, something unseen, writes its gravity across these orbits. A hidden sculptor at the edge of the system. The deeper astronomers looked, the stranger the script became. Computer simulations seeded the outskirts of the solar system with hypothetical bodies, asking how invisible giants might shape the frozen diaspora. Again and again, the same portrait emerged. An object 5 to 10 times Earth's mass, circling at hundreds of astronomical units, corralling icy debris into its present formation. Remove the phantom planet, and the order dissolves into chaos. Insert it, and the equations breathe with uncanny alignment. Mathematics does not lie, but it does tease. It presents the possibility of truth and dares us to prove it. Instruments joined the chase. The Subaru telescope, with its hyper-supreme cam, spread its gaze over wide tracts of sky, pixel by pixel, frame by frame, searching for a faint dot that crawls instead of twinkles. The infrared eyes of WISE scoured the heavens for hidden warmth, mapping thousands of stars and countless asteroids, yet left the planet ambiguous, constrained but not erased. Each survey is both progress and paradox, narrowing the realm where the world could hide, yet reminding us that even in the age of great observatories, shadows remain thick. The unseen body grows less mythical and more architectural, as though the solar system's very frame insists it must exist, even if the light does not yet admit it. And then comes the escalation, the deepening of mystery. The numbers suggest not merely a world, but a titan with consequences that ripple into everything we thought we knew. A planet of such mass on such an orbit would need 10,000 years to complete a single revolution around the Sun. Its seasons would last longer than the span of human civilization. Its perspective on time would render our history less than a momentary spark. This orbit, so vast and cold, would be more exile than home. To imagine it circling, patient and eternal, is to realize how small Earth's rhythms truly are. Even more troubling is the angle. The hypothetical orbit does not align neatly with the others. It is inclined, tipped as if rejecting the symmetry of the 8 known planets. Such a tilt hints at violence, at migration, capture, or scattering during the solar system's chaotic youth. Perhaps this hidden world was born closer in, near the giants, and flung outward by Jupiter's gravity in a primordial slingshot. Perhaps it drifted in from another star system entirely, a rogue captured in a rare gravitational embrace, or perhaps it was always there, coalescing in the outskirts of the solar nebula where sunlight was only a myth. Each possibility reframes our origin story. Each one demands humility. The escalation sharpens with speculation of influence. Could such a planet have tilted the entire plane of the solar system itself? A silent puppeteer shifting the orientation of everything under the sun? Astronomers note that the plane of planetary orbits is offset by 6 degrees from the sun's equator. Coincidence, perhaps. Or perhaps a massive, distant companion has been tugging for billions of years, leaving its mark not in light, but in geometry. And if its influence reaches that far, what else might it have touched? The Oort cloud, a shell of icy fragments billions of kilometers away, may be stirred by its pull, sending comets inward on catastrophic pilgrimages. It is not unthinkable that mass extinctions on Earth, moments when evolution was burned and reset by falling ice and stone, trace their origins to a distant, unseen planet nudging a comet from its slumber. The threat is not immediate. If such a planet exists, its orbit is remote, its path indifferent to our fragile world. But the implication lingers. The solar system is not a placid clockwork, but a wilderness shaped by predators we have yet to see. The comfort of knowing all the players is gone. In its place grows a new humility, that the story of the sun's children is still being written, that the cast is incomplete, that even the opening act of our cosmic history hides scenes we have not watched. The escalation deepens further in the speculations of some. What if it is not a planet at all? What if it is something stranger, a primordial black hole, no larger than a fruit, carrying the mass of Earth within its darkness? Such an object would betray itself only in its gravitational fingerprint, the very signature we now suspect. It would be invisible, undetectable in reflected light, silent even in infrared. Only through lensing, through the bending of starlight as it passes behind, could we hope to glimpse its existence. To imagine such a thing circling within our own solar system is to step into nightmare territory. The abyss not billions of light years away, but at our doorstep, orbiting the same sun, unseen and eternal. Whether planet or black hole, captured rogue or native exile, the escalation is the same. The solar system we thought we knew may be far more complex, far more haunted than textbooks admit. It is not a finished model of elegance, but a living structure with gaps, wounds, and mysteries. The suspicion that a massive body still lurks nearby is not only a scientific problem. It is a crack in our confidence, a reminder that even at home we are still explorers, stumbling in the dark. And it is precisely this realization that turns suspicion into awe, and awe into urgency. We must keep searching, for whatever orbits out there, silent and unseen, has already shaped the destiny of our world in ways we are only beginning to imagine. The search does not end with the suspicion of patterns. It grows hungrier, stretching deeper into the sky, calling on instruments built for the faintest whispers. Astronomers turn to telescopes that do not just see but accumulate, stacking photons over hours until the invisible begins to register. Subaru in Hawaii spends night after night tiling the heavens, stitching together mosaics so vast that the planet, if it moves, would betray itself by a crawl across seasons. The data is relentless. Terabytes upon terabytes of star fields, each frame a possible hiding place. The work is patient, almost monastic. Somewhere in the repetition lies the possibility of revelation. Simulations become the silent partners of these observations. Vast computers render millions of digital solar systems, populating them with icy fragments and hypothetical giants. When the phantom world is included, the clusterings appear again, the tilted orbits regain their strange synchrony, the chaos resolves into order. Remove it, and the system frays, its balance collapses. Each iteration deepens the conviction. The unseen mass is not a ghost story, but a gravitational necessity. Science does not call it belief, but the feeling is close. A presence begins to loom in the imagination, given weight by equations, drawn into focus by the stubborn alignment of orbits. It becomes harder to deny and easier to wonder. Yet every instrument has its limits, every survey, its blind spots. The infrared gaze of WISE mapped the sky, sensitive enough to detect brown dwarfs nearby, yet it returned silence for Planet 9. Critics wield this silence like a blade, arguing the world cannot exist. But silence is not the same as absence. Perhaps the planet lies in regions never fully scanned. Perhaps its albedo is darker than expected, cloaking it in charcoal dimness. Perhaps its temperature is colder, its radiation weaker, its signal diluted beneath thresholds of detection. Silence narrows possibilities but does not erase them. The hunt continues because the gravitational scars remain. The sky has not exonerated itself. Escalation emerges in every corner of the data. The clustering of perihelia is only the beginning. Some trans-Neptunian objects show extreme inclinations, their paths whipped high above the planetary plane, almost perpendicular to the familiar order of orbits. Such oddities make sense only in the presence of a massive perturber, a world whose gravity can twist long-period objects into acrobatics. Even more unsettling are the retrograde candidates, bodies orbiting the sun in directions opposite to the planets. These are not random rebels. They too may be the children of a distant shepherd, captured and contorted in its unseen influence. Each anomaly is a signature, a fingerprint of something vast enough to reorder the cosmic choir. The evidence builds not like a crescendo, but like a tide, slow and undeniable. Astronomers publish, debate, counter, refine. Each paper is both brick and question mark, strengthening the walls of the hypothesis while leaving open doors for doubt. But the deeper one studies the outskirts, the harder it is to explain the architecture without invoking the missing architect. The system looks sculpted, and science abhors uncaused sculpture. If no planet exists, then new physics must. If no planet exists, then our assumptions about the distribution of primordial matter must collapse. Either outcome rewrites the story. Either outcome means our solar system is stranger than the models that once felt so complete. At conferences, whispers circulate of how many more objects display the alignment, how many outliers refuse to be dismissed. In quiet offices, astronomers overlay sky maps with probability distributions, narrowing the region where the world might dwell. Each narrowing fuels the urgency of the search. And in the meantime, the public imagination stirs. Articles speak of Planet 9 as though it is a certainty, a neighbor yet to be introduced. The mystery begins to live beyond academia, echoing through culture, myth reborn in data. It becomes a reminder that even in an age of satellites and surveys, the frontier has not retreated. It has only shifted to the places where patience and precision are required. The deepening is not only scientific, but emotional. To imagine a hidden world circling for billions of years, indifferent to us, is to be reminded of scale. Its orbit dwarfs our histories. Its seasons outlast civilizations. While humans rose, fought, built, and forgot, this world, if it exists, has not even crossed a fraction of its path. It would be a planet of patience, a monument to slowness, a world that lives at the pace of stars rather than men. To confront such a being is to feel the poverty of human time, to measure our urgency against cosmic leisure. And in that contrast lies both dread and awe. The escalation peaks when speculation turns darker. If such a body stirs the Oort cloud, then every comet that plunges inward, every shard of ice that strikes Earth, may trace its journey back to that unseen hand. The impacts that ended eras, that extinguished species and paved the way for others, may have been orchestrated not by chance, but by the rhythm of a hidden neighbor. In that sense, the unseen planet is already written into Earth's story, its silence shaping the trajectory of life. The threat is distant, diffuse, measured in epochs rather than moments. Yet the realization that Earth's history has been touched by an unseen neighbor makes the mystery personal. It is no longer just about ice and orbits. It is about us. And so the deeper investigation becomes a meditation. We chase the faintest dots across crowded skies, not only because science demands it, but because mystery seduces us. To know is to control, but to not know is to feel alive. Somewhere out there, a planet may orbit that does not care for our names or our maps. Somewhere out there, a shadow moves with the gravity of a god and the invisibility of a ghost. We do not know its face, but we know its fingerprints. And those fingerprints mark not only the frozen outskirts of the solar system, but the quiet corridors of our own imagination. Its presence is not declared in light, but in the distortions of order. The Kuiper Belt's outer bodies are like reeds bent in one direction, their orbits circling not where chance would have placed them, but where something unseen has commanded them. The suspicion hardens with each discovery, yet still the question gnaws. How can something so vast remain hidden? The deeper the search goes, the more unsettling the silence becomes. For every new icy fragment whose path whispers of a shepherd, the sky offers no glimpse of the shepherd itself. It is a riddle wrapped in darkness, daring us to solve it without sight. Astronomers begin to imagine the extremes. A world 5 to 10 times Earth's mass, orbiting between 400 and 800 astronomical units from the Sun, would be dim beyond comprehension. Its sunlight, diluted into near-nothingness, would trickle back to us as a faint ember, drowned in the background brilliance of stars. Even the most powerful telescopes would struggle to tease it from the tapestry. The planet could be hiding in the galactic plane, where millions of stars clutter every image, masking faint wanderers. Or its surface could be cloaked in darkness, a low albedo that reflects almost nothing. Every explanation is plausible, and each adds to the discomfort. A planet can be both immense and invisible if distance and shadow conspire long enough. And then come the simulations of orbital resonance. The unseen world, if it exists, does not merely sculpt orbits. It stabilizes them, creating long-lived families of trans-Neptunian objects. Without its presence, these populations would disperse into randomness over cosmic time. With it, their alignments persist like constellations preserved in gravity's memory. This is not coincidence, but choreography. The solar system behaves as though it has a hidden conductor, one whose baton we have not yet seen. Remove the conductor, and the music dissolves. Leave him in place, and the harmony continues. It is in that harmony that suspicion becomes conviction, though conviction without proof is the most fragile state of all. Escalation is not only scientific, but emotional, because the implications ripple outward. If the planet is real, then it may not only explain orbital anomalies, but also the tilt of the solar system itself. Our planets circle the Sun on a plane misaligned with the Sun's equator by 6 degrees, an oddity long noted but never fully explained. A massive, distant planet could account for this tilt, tugging gently over billions of years until the entire architecture shifted. In this light, Planet 9 is not an accessory to the solar system. It is a hidden pillar, shaping the structure from the shadows, rewriting the very geometry of home. The thought extends further, to the Oort cloud and beyond. A distant giant could stir the icy shell that surrounds the solar system, nudging comets onto paths that plunge them inward. Some of those comets may have struck Earth, seeding it with water or extinguishing species in sudden catastrophic moments. The fingerprints of the hidden world may therefore already lie on Earth's oceans, on its fossils, even on us. It is a possibility both terrifying and intimate, that life on Earth is entangled with the gravity of a planet we have never seen. Our survival, our evolution, our very presence may be bound to an orbit that takes tens of thousands of years to complete. But the deeper the mystery grows, the more extreme the speculations become. Perhaps it is not a planet at all, but something stranger, something darker. A primordial black hole, forged in the infancy of the universe, could possess the mass required and yet be no larger than a fruit. It would not reflect sunlight, it would not radiate warmth, it would be invisible, save for its influence on the worlds around it. To find such an object would require techniques beyond traditional astronomy. Microlensing events, when its gravity bends the light of background stars, or faint emissions from dark matter annihilations clustered near its well. To imagine such a thing orbiting our sun is to feel the boundary between science and myth blur, for black holes belong to the distant cosmos, not to our doorstep. And yet the equations do not forbid it. The silence of the sky almost seems to invite it. Every hypothesis, whether planet, rogue capture, or black hole, deepens the enigma. Each one requires us to redraw the solar system's history. If it is a planet, how did it get there? Did Jupiter and Saturn's migrations sling it outward? Did the Sun capture it from another star during its cluster years? If it is a black hole, then the solar system holds not just planets and comets, but relics of the Big Bang itself. Each possibility unsettles us, because each implies that we do not yet know the place we call home. The solar system, which we once imagined a closed system, is revealed as an unfinished manuscript, with chapters missing and margins smudged. The escalation, then, is not only about the mystery deepening, but about our place in it. Humanity stands at a threshold, peering into a darkness that both resists and demands discovery. To find Planet 9 would be to rewrite the textbooks, to admit that even in the year of advanced telescopes and interplanetary missions, we are still children in a forest, counting trees without knowing the forest's edge. And if we fail to find it, the mystery does not vanish. It only grows stranger, for then we must explain the cosmic choreography without its hidden conductor. Either answer forces us into humility. Either answer forces us to admit that the solar system is vaster, stranger, and more unsettled than we ever believed. Theories begin to gather like clouds on the horizon, each one offering not just an explanation, but an invitation to reimagine the solar system. The simplest is also the boldest. That there is indeed a ninth planet, a super-Earth or mini-Neptune, born of the same dust and gas that made Jupiter and Saturn, but cast into exile during the system's turbulent youth. In this telling, Planet 9 formed closer to the Sun, perhaps between Jupiter and Neptune, before gravitational skirmishes flung it outward into a vast, eccentric orbit. There it lingered, cooling and darkening, condemned to circle the Sun on a path so wide that it takes tens of thousands of years to return to the same stars. Such a planet would be massive enough to sculpt the outer Kuiper belt, to tilt the solar system's plane, to write its invisible music into the motions of smaller bodies. It would be a familiar kind of stranger, planetary in form, alien only in distance. But there are other possibilities, stranger still. Some astronomers suggest it may not be native at all, but captured. In the sun's infancy, when it was born amid a cluster of stars packed far more tightly than the sky we know today, close encounters were inevitable. A rogue planet, wandering between stars after being ejected from its own system, might have drifted close enough to be snared by the sun's gravity. If so, Planet 9 would be an interstellar immigrant, a visitor who became family. Its orbit, inclined and elongated, would reflect this violent adoption, a scar of a chaotic beginning written in its eternal path. If true, then our solar system is not a sealed story, but an open one, mingling with the histories of other suns. And then comes the possibility that challenges the very definition of planet. What if it is not a sphere of rock and ice at all, but a black hole? A primordial relic born in the chaos after the Big Bang, compressed to a horizon no larger than a fruit, yet weighing as much as several Earths. Such an object would be utterly invisible in light, betraying itself only through gravity. It would be beyond the reach of traditional telescopes, detectable only through the bending of starlight in microlensing events, or through delicate traces of dark matter interactions. If Planet 9 is such a black hole, then the solar system is not merely a family of planets and comets, but also a crypt holding one of the universe's most ancient relics, a fragment of cosmic infancy circling quietly in our own backyard. Each theory forces the imagination wider. If a planet, how did it form so far from the sun, where material was sparse and accretion should have been slow? If captured, what does that mean for the sun's early companions, for the unseen histories of stellar nurseries? If a black hole, what other relics of the universe's birth still haunt us, unseen and unsuspected? Each path opens a corridor deeper into mystery. Each hypothesis humbles our certainties. Theories multiply, not because the evidence is weak, but because it is tantalizingly incomplete, leaving just enough room for speculation to flourish. Other speculations veer toward the radical. Some wonder if the alignments are illusions, the products of observational bias in the regions of sky astronomers have scanned. If so, the mystery is not a planet, but a mirror, reflecting the limits of human method rather than the presence of a hidden world. Others suggest collective gravity, hundreds of small icy bodies conspiring together to mimic the influence of a single massive one. This would make the solar system not a tale of giants, but of multitudes, an orchestra of whispers instead of a single unseen conductor. Even this explanation, though less dramatic, would rewrite our understanding of the outer solar system, turning it from a scattered debris field into a coherent, self-organizing structure. What ties all these theories together is their refusal to allow complacency. They remind us that what we see is never all there is, that data carries both truth and deception, that the universe loves to blur the line between signal and noise. Einstein warned that imagination is more important than knowledge, and here, at the edge of the solar system, imagination and knowledge are forced into partnership. Hawking reminded us that the universe is stranger than we can imagine, and Planet 9, or what masquerades as it, seems determined to prove him right. Each theory is a gesture into that strangeness, a way of saying, we do not know, but we will not stop asking. The beauty of these speculations is not only in their potential truth, but in their philosophical reach. To consider a hidden planet is to remember that our maps are provisional, our categories temporary, our certainties fragile. To consider a captured rogue is to admit that the solar system is not a fortress, but a porous frontier, shaped by encounters with the wider galaxy. To consider a primordial black hole is to acknowledge that the universe's oldest secrets may not dwell in faraway galaxies, but orbit silently beside us. Each possibility stretches not just astronomy, but philosophy, forcing us to rethink the boundaries of what we call home. And so the theories are not just answers waiting to be tested. They are mirrors, reflecting our hunger for completion, our discomfort with mystery, our need to believe the cosmos can still surprise us. Whether the truth is planetary, black hole, collective gravity, or illusion, it will not diminish the awe. The search itself has already enlarged the solar system in our minds, reminding us that the unknown is not always out there, in distant galaxies or other universes, but here, in the darkness just beyond Neptune, in the silence of our own celestial backyard. Science does not advance by certainty alone. It advances by the wrestling of doubt and imagination. Planet 9, whether real or illusion, has become a crucible where both wrestle without resolution. Some astronomers remain unconvinced, insisting the alignments of distant icy bodies may be artifacts of selection, products of where our telescopes have looked and where they have not. They remind us that the sample size is small, the sky vast, and that statistics can seduce with patterns that dissolve under fuller scrutiny. Others counter that the consistencies are too sharp, the clustering too stubborn, the coincidences too improbable. Between them, the debate itself becomes evidence of the mystery's depth. For if the answer were simple, it would have already been settled. Theories multiply like shadows under flickering light. Beyond the classical image of a super-Earth lies the possibility of more exotic explanations. Some envision a dark planet, composed not of familiar matter but of forms we barely understand. Dense collections of particles that interact only weakly with light, yet still wield gravity's grip. Such an object would be nearly invisible to telescopes, detectable only in its influence on other bodies. In this scenario, Planet 9 would not merely be a planet we've failed to see, but a bridge into new physics, a local manifestation of the dark matter that shapes galaxies. The solar system, in this telling, would become not just a home, but a laboratory, harboring within its outskirts a piece of the universe's greatest mystery. Others imagine a rogue, not captured but still passing. What if the patterns are not the signature of an enduring neighbor but the temporary brush of a passing giant, a body that drifted close enough in the recent astronomical past to reorder the Kuiper belt before continuing its lonely journey into interstellar night? The idea is unsettling in its impermanence. It suggests the solar system is not a closed clockwork, but an open shoreline where tides of wandering masses occasionally wash through, leaving scars before retreating. If true, the anomaly is not an unseen companion, but a ghost, long gone, its influence carved into the frozen orbits it left behind. Even more daring is the speculation that Planet 9 could be the scar of cosmic inflation itself, a fragment of the primordial turbulence that inflated the universe from quantum seed to vast expanse. In such models, fluctuations in the early universe could have birthed compact, massive objects at random scales, some of which might survive as black holes, others as dense rogue planets. If one lingers here, orbiting the Sun, it would be a fossil not just of the solar system's birth, but of creation itself. To find it would be to find a relic of the universe's first heartbeat. Each theory is like a mirror, angled differently, reflecting the same enigma in a new hue. Whether ordinary or exotic, captured or native, solid planet or black hole, the hypothesis unsettles because it redraws boundaries we thought firm. If a planet, it expands the solar system beyond what we thought complete. If a black hole, it pulls cosmology into our backyard. If an illusion, it humbles us with a reminder that even the best instruments and models can mislead. There is no outcome that leaves the cosmos unchanged. Every answer stretches our imagination wider than before. This is why the mystery endures, why it fascinates beyond academia. It is not just about adding one more world to the roster. It is about the humility that comes when the familiar is revealed as incomplete. It is about realizing that the solar system is not a finished museum, but a living wilderness, still capable of surprise. To acknowledge that we might share the sun with an unseen neighbor, whether a planet a black hole, or something stranger, is to acknowledge that mystery breathes even in the places we thought we knew best. And so the theories persist, weaving science with speculation, data with imagination. Each is both fragile and profound, awaiting the day when a telescope confirms or disproves them. But until that day, Planet 9 remains both presence and absence, a mass written into the orbits of icy bodies but erased from the sky, a riddle that demands both patience and wonder. Whether it exists or not, it has already achieved something remarkable. It has forced humanity to look again at the familiar, to admit ignorance in the heart of knowledge, to feel awe in our own backyard. And that awe, perhaps, is the most enduring truth of all. Speculation pushes farther, beyond what is comfortable, into places where science begins to brush against philosophy. If Planet 9 exists, then why has the universe permitted it to remain hidden until now? Some suggest it is nothing more than probability, a simple accident of distance, dimness, and sky coverage. But the human mind rarely accepts accidents so easily. We want meaning in the silence. We want purpose in the delay. And so the theories stretch, touching even the edges of metaphysics, where the universe itself feels like a storyteller, withholding a twist until the final act. The possibility of a hidden planet is no longer just a scientific riddle. It becomes a mirror reflecting our hunger for completion. One of the most provocative ideas is that Planet 9 could be a captured remnant from another star, not merely foreign to us, but carrying with it the history of an alien system. Imagine a time when the sun was still young, a newborn among a crowded cluster of siblings, stars huddled together in a nebula like sparks in the same ember. Close passes were inevitable. Planets, loosened from weaker orbits, could drift free. And in that chaos, the sun could have stolen one, binding it into a new family it did not choose. If true, then our solar system is not only ours. It is a mosaic stitched from cosmic theft, carrying within it the fingerprints of another star long gone. The notion unsettles because it broadens our identity. Earth, Mars, Jupiter, all may be siblings, but Planet 9 would be the adopted child, older, stranger, carrying secrets we cannot yet decipher. Other theorists turn to the abyss of dark matter itself. What if the hidden sculptor is made not of atoms, but of the invisible matter that dominates the cosmos? If a dense clot of dark matter lingers in the outskirts, massive enough to perturb orbits, it would be invisible to light but undeniable in gravity. Such a discovery would collapse two mysteries into one. The question of Planet 9 and the question of dark matter solved together in a single revelation. It would mean that our own solar system is not a bystander to cosmic mysteries, but a participant, its architecture shaped by the same unseen matter that governs galaxies. Such a truth would not merely expand astronomy. It would redefine cosmology, turning our backyard into the laboratory of the universe's deepest secrets. And yet, there remains the radical humility that perhaps there is no Planet 9 at all. Perhaps the alignments we see are phantoms, drawn from small numbers and skewed surveys. Perhaps, as we widen our gaze, the patterns will dissolve, the anomalies will scatter into randomness. This outcome, though less dramatic, carries its own kind of revelation. It would remind us that science is not about what we want to be true, but what is. It would expose the danger of our storytelling instinct, our hunger for coherence where none exists. And it would force us to refine our models, to imagine new ways in which countless small bodies might conspire to mimic the influence of a single large one. Even in absence, the lesson would be profound. That humility is the first law of knowledge, and that the universe resists our narratives as often as it fulfills them. What unites all these theories, no matter how mundane or wild, is the reminder that the solar system is not finished. It is a living question mark, an evolving riddle. For centuries, astronomers believed discovery was ending, all major planets charted, all great patterns known. But Planet 9, whether real or illusion, reopens the frontier. It whispers that there is always more, that the cosmos is never done surprising us, that the story of the sun and its children is not a closed book, but an unfinished epic. To dwell in that uncertainty is both humbling and liberating. For in uncertainty lives wonder, and in wonder, the reason we look up at all. The hunt has turned from whispers to instruments, from speculation to the cold machinery of science. To chase a world too dim for human eyes demands tools of exquisite patience. Wide-field surveys sweep the heavens, capturing oceans of stars in their gaze. The Subaru telescope, with its vast camera, tiles the sky in silent mosaics, frame after frame, each image a question. Does the wanderer lie here? The planet, if it exists, betrays itself only by motion, a crawl so slow it takes months or years to notice. So astronomers return, season after season, subtracting today's sky from last year's, watching for a single dot that refuses to stay still. The work is tedious, monastic, almost prayerful. Yet within this patience lies the chance of revelation. Infrared eyes have also searched. NASA's WISE mission swept the entire sky, mapping the faint heat of brown dwarfs and asteroids. It found no Planet 9, but it did not close the case. Sensitivity drops in crowded regions. Shadows stretch where the galactic plane drowns faint signals. The surveys constrained possibilities, narrowed the hiding places, but they did not erase them. Silence is not absence. It is an invitation to look harder, deeper, longer. Every null result sharpens the hunt, pointing toward regions still unexamined, motions still too faint to discern. Soon, new instruments will sharpen that gaze. The Vera C. Rubin Observatory, with its legacy survey of space and time, will map the heavens with a depth and cadence unlike anything before. Night after night, it will return to the same fields, building an atlas of the transient sky. Supernovae will flare, asteroids will scurry, comets will trace their arcs, and perhaps, among them, a slow-moving shadow will emerge, a dot migrating across years of data, the long-sought wanderer. The search will no longer be guesswork, but systematic, relentless, comprehensive. If Planet 9 exists, Rubin is the eye that should see it. Other approaches join the effort. The Gaia spacecraft, mapping the positions and motions of billions of stars, may catch the subtle tug of an unseen mass, a faint acceleration in the sun's own journey through the galaxy. Stellar occultations, when a distant object passes, in front of a star, offer another path. By measuring shadows with exquisite precision, astronomers may glimpse anomalies that betray a larger neighbor. Even the search for microlensing events, stars that brighten briefly as an unseen object bends their light, remains on the table, should the possibility of a primordial black hole demand attention. Each tool is a sense added to humanity's perception, each method an extension of our fragile eyes. But the tools are not only telescopes, they are also equations, models, algorithms. Computers sift through terabytes of images, training machine vision to distinguish a faint planet from the noise of stars and galaxies. Simulations run for millions of virtual years, testing the gravitational dance of thousands of bodies with and without the hidden giant. When the alignments survive only in the presence of the phantom, the argument strengthens. When they dissolve without it, the argument weakens. The search becomes not just about seeing, but about reasoning, not just about evidence, but about coherence. Science is both telescope and thought, both data and imagination bound by rigor. The pursuit is global, a collaboration stretching from mountaintop observatories to orbiting satellites, from high-powered computing clusters to the notebooks of theorists. The prize is not merely a planet, it is the restoration of order, the reconciliation of equations with observation, the closing of a gap that refuses to stay closed. To find Planet 9 is to bring harmony back to the outer solar system, to align what we see with what gravity demands. To not find it is to admit that something deeper, stranger, is shaping those orbits. Either outcome is discovery. Either outcome enlarges the universe we think we know. And so the instruments turn, the sky is scanned, the data piles higher. Somewhere in that mountain of photons may lie the faint track of a hidden world, waiting for patience to reveal it. Science proceeds not with sudden revelation, but with the slow accumulation of weight, until the balance tips, until the unseen is undeniable. The search for Planet 9 is not merely about finding a planet. It is about proving to ourselves that even here, within the reach of our own star, mystery remains. That the universe still asks us to earn its secrets. The search is not merely technical, it is philosophical in its persistence. Each night that telescopes sweep the sky without reward, the mystery grows heavier, not lighter. Every null result sharpens the contradiction. If such a massive body exists, why has it escaped us? The tension feeds not despair, but determination, because science thrives on resistance. Failure does not silence the question, it makes the question louder. It drives us to invent new methods, to push instruments beyond their design, to search the sky with different eyes. In this struggle, the hidden world has already reshaped astronomy, demanding patience on a scale that mirrors its own glacial orbit. Subaru continues its vigil. The telescope stares into regions predicted by simulations, probing the star-cluttered galactic plain where camouflage is thickest. Each exposure captures millions of points, but astronomers seek the one point that betrays motion. They stack images, subtract frames, and sometimes glimpse objects never seen before, faint asteroids, distant dwarfs, icy fragments. Each discovery is celebrated, but each also whispers the same absence. Not yet, not the giant. The work accumulates like sediment, building layer upon layer of possibility and exclusion. Slowly, the territory where Planet 9 can hide shrinks, as though the darkness itself is being cornered. The anticipation now leans heavily on the Vera Rubin Observatory. Its immense mirror and sweeping cadence promise a revolution. Over 10 years, it will capture the entire southern sky, again and again, each pass adding detail to the map of motion. In that ocean of data, the unseen world should not remain invisible. If it exists, Rubin will watch it crawl across the sky, a dot against eternity, patient but betraying itself to persistence. The thought fills astronomers with both excitement and unease. For with such power comes the certainty of an answer, and answers always change the world. To find the planet is to complete the map with a new titan. To not find it is to unravel explanations, to admit that our theories themselves must be rebuilt. Other instruments extend the net. Gaia's astrometric precision measures the motions of stars so finely that even the sun's acceleration can be traced. If a distant planet tugs on the solar system, Gaia may sense the pull indirectly, reading the handwriting of gravity in stellar parallax. Radio telescopes too may join the chase, measuring timing variations in pulsars to test for the subtle influence of a nearby mass. The hunt becomes multidisciplinary, a convergence of tools as diverse as the theories they serve. The hidden world has become not just an object of astronomy, but a challenge to ingenuity itself. Even the prospect of falsification carries weight. Some scientists argue that the failure to detect the planet within a decade may be proof of its non-existence. If Rubin's survey, with its depth and reach, reveals no wanderer, then the hypothesis may collapse. But even this outcome is not defeat. It would mean that the alignments, the clustering, the tilted planes must have other causes we do not yet understand. It would force us to rethink the collective behavior of the outer solar system, to imagine interactions among countless small bodies that mimic the presence of one giant. It would be a reminder that the cosmos deceives as well as reveals, that mysteries often transform rather than vanish. The ongoing search, then, is more than an attempt to pin coordinates to a hypothetical planet. It is an exercise in humility, a confrontation with the limits of our instruments, our methods, our imagination. Every new observation, whether confirming or denying, teaches us something about the outskirts of the solar system, about the architecture of orbits, about the boundaries of our reach. The hidden planet is already a teacher, whether or not it is real. Its greatest lesson may be that discovery is not the finding but the seeking, not the proof but the refusal to stop looking. The sky is not passive while we wait. Data streams from telescopes night after night, a river of photons that must be sifted and sorted, compared against catalogs that already stretch beyond comprehension. In this torrent, astronomers hope the unseen world has already been caught, recorded unknowingly in images where it hides as a faint, slow-moving ember. The challenge is not only to observe, but to notice. Computers are trained to comb through archives, to measure the positions of millions of points, and return again years later to ask, which of these dots has shifted? Somewhere in this archive, the evidence may already lie dormant, waiting only for patience and pattern recognition to awaken it. Meanwhile, theorists refine their predictions. Each new trans-Neptunian discovery, each icy fragment added to the map, sharpens the models. The more objects found with aligned perihelia, the stronger the case for a massive perturber. Their orbits are input into simulations that span billions of years, testing stability with and without the phantom world. Again and again, the patterns endure only when the hidden mass is included. The range of possibilities narrows. 5 to 10 Earth masses, orbiting hundreds of astronomical units away, inclined by perhaps 20 degrees. With every refinement, the invisible grows clearer. It is paradoxical, but true. We are beginning to know the unseen by the clarity of its absence. And yet, there is caution. Instruments like Rubin and Gaia are built to leave no stone unturned. If, after years of scanning, the planet is not revealed, the weight of evidence may shift. Then we will face a deeper puzzle. How to explain the clustering without invoking a giant? Some propose collective gravity, the combined tug of countless small objects behaving as one. Others point to subtle resonances with Neptune, a hidden order emerging from the interplay of known giants. Still others suggest statistical illusion, an accident of where we have looked most often. Each alternative shifts the mystery, but does not dissolve it. The solar system refuses to close its book. In the laboratories of Earth, physicists watch the debate closely. For if the phantom world is not a planet, perhaps it is something stranger. A primordial black hole remains one candidate, detectable not by reflected light, but by microlensing events when it passes before distant stars. Experiments sensitive to dark matter also stir, wondering if a local concentration of the invisible could account for the same signatures. Even particle physicists find themselves drawn into the orbit of this question, for to solve it may connect cosmology with quantum mechanics, the outer solar system with the fabric of the universe itself. The search for Planet 9 has already become more than astronomy. It is a crossroads of disciplines. Science, though, does not proceed with certainty. It proceeds with doubt. Each telescope time allocation, each paper, each new icy object discovered is another step in a long argument between what the data says and what the models demand. The search may take years, even decades. The answers may prove stranger than we expect, or simpler than we hope. But in either case, the effort reveals something profound, that even in our own solar system, within reach of our sun's warmth, mystery endures. The unseen planet, whether real or not, has already changed how we look at the cosmos. It has forced us to admit that discovery is not finished. It has forced us to remember that wonder still hides close to home. The mystery does not vanish as instruments sharpen. Instead, it deepens into the realm of theory, where physics itself is asked to stretch. If a massive planet orbits unseen in the outer darkness, then its gravity is not just a local disturbance, but a participant in the grander frameworks of relativity and cosmology. Einstein's vision of space-time, bent and sculpted by mass, implies that even a hidden world far beyond Neptune writes its curvature into the Sun's dominion. The clustering of orbits is geometry revealed in slow motion, the faintest echo of general relativity playing out over millions of years. To hunt Planet 9 is, in a quiet way, to test Einstein again, to see if geometry alone accounts for what we observe or if something stranger lurks behind the veil. Other frameworks are invited into the speculation. Cosmic inflation, that furious expansion in the universe's infancy, may have birthed primordial black holes scattered like fossils across the cosmos. If one survived near us, orbiting the Sun unseen, then Planet 9 would not be a planet at all, but a relic of creation itself. The solar system would be not merely a product of its nebula, but a host to an object older than stars, older than galaxies, a seed of gravity born in the first heartbeat of time. To confront such a possibility is to realize that the boundary between cosmology and local astronomy is illusory. The infinite is not far away. It may orbit beside us, cloaked in silence. Theories of multiverses even touch this question. Some physicists speculate that unseen gravitational effects could hint at interactions with dimensions beyond our own, or at echoes of other universes, brushing ours at subtle scales. Though such ideas hover at the edge of science, they share the same root as Planet 9, anomalies that demand explanation. The hidden world becomes a symbol of everything unaccounted for, a gravitational riddle that points outward to the deepest mysteries of existence. Whether the answer is planetary, black hole, or something beyond comprehension, it reminds us that physics itself is provisional, a ladder we climb without knowing how many rungs remain. Even quantum fields are whispered into the discussion. Some theorists imagine a hidden particle environment in the outer solar system, subtle interactions shaping orbits in ways that mimic a planet. If so, the clustering of distant icy bodies could be not the signature of mass, but of fields, invisible but pervasive. Such an answer would connect the smallest scales of physics with the largest structures of the solar system, binding quanta to planets in one continuous fabric. It is speculative, yes, but speculation is the engine of science. Without it, anomalies remain only puzzles. With it, they become doorways. Einstein once said the most incomprehensible thing about the universe is that it is comprehensible. Theories of Planet 9, whether grounded in known dynamics or soaring into speculation, are attempts to make sense of the incomprehensible. Each one is a lens, sharpening or distorting, but always focused on the same question. Why does the outer solar system look as though something is sculpting it? And beneath that question lies another. What else, beyond planets and stars, lies waiting to be found? Theories do not answer finally. They guide, they provoke, they open pathways. The hidden planet is less a solution than a summons, asking us to stretch imagination and science until they meet. The great strength of the Planet 9. Hypothesis is not only in its ability to explain orbital patterns, but in the way it has forced science to expand its toolkit. The solar system is no longer seen as a finished set of planets and leftover debris, but as a dynamic structure still revealing its architecture. Each theory sharpened by this mystery reshapes how astronomers and physicists imagine the Sun's domain. The simplest, that of a massive icy super-Earth, offers continuity, a planet like those common in other star systems, finally found in ours. It would explain not only the clustering of orbits, but also the tilt of the solar system itself. If discovered, it would mean our system is not an anomaly among exoplanets, but finally conforms to the patterns we see elsewhere in the galaxy. It would be less exotic, but profoundly humbling. How could we miss what other stars seem to display so readily? Other theories push more daringly. A captured rogue planet speaks of cosmic encounters we once thought rare. It suggests that the Sun's birth cluster was crowded with siblings whose gravity brushed against ours, trading planets like flung stones in a childhood game. If one was caught, it would carry not just its own composition, but the signature of another star's chemistry, a messenger from beyond, orbiting under our Sun's light. Such a discovery would blur the line between our solar system and the galaxy at large, reminding us that stars are not solitary in their youth, that their systems can mingle and exchange, weaving cosmic kinship into planetary origin. Stories. And then there is the most radical vision, a primordial black hole, invisible yet present, its mass bending space-time in silence. It would demand entirely new methods to prove, such as searching for gravitational microlensing events, where background stars brighten as the object passes before them. Such a discovery would connect planetary science to cosmology, bringing the relics of the Big Bang into direct orbit around the Sun. It would mean our solar system is not just a nursery of planets, but a museum of the universe's earliest fossils. The implications would stretch from dark matter theories to the fate of the cosmos itself. A black hole as Planet 9 would not just rewrite the solar system. It would tether our neighborhood to the universe's origin. Theories of collective gravity remain on the table as well, suggesting no single hidden giant, but rather the combined influence of countless icy bodies conspiring to create the illusion of one. If true, then the solar system's edge is not merely a graveyard, but a complex society of small worlds, shaping each other through shared gravity. Such a revelation would highlight the power of many over one, the subtle choreography of multitudes producing the same order as a single titan. It would be less cinematic, but no less profound, for it would mean that even the smallest worlds, when acting together, can leave a signature written across billions of miles. The challenge of these theories is not only to explain the data, but to endure time. Each must face the scrutiny of new surveys, the relentless narrowing of Rubin's eye, the ongoing accumulation of icy orbits added to the ledger. Each theory is provisional, a sketch awaiting confirmation or erasure. Yet their very existence proves the vitality of science. The hidden world has already expanded imagination beyond comfort, connecting the outskirts of the solar system to galactic history, to cosmology, to quantum speculation. It has reminded us that mystery is not a failure, but a feature, a compass pointing always outward. In this way, Planet 9 is both specific and symbolic. It may be a planet, a rogue, a black hole, or nothing at all. But as a question, it has already become one of the most powerful in modern astronomy, bridging data and philosophy, pushing science into new domains. It teaches that the unknown is not always distant. Sometimes it circles near, patient and silent, asking us to see. Speculation evolves into a kind of storytelling, for each theory about the hidden world is also a narrative about how the solar system itself was born. The standard picture once painted a neat sequence. Dust and gas collapsed, planets assembled, the giants migrated slightly, and stability followed. But Planet 9, if real, tears open that simplicity. It forces new creation myths. Perhaps in the early chaos, when Jupiter and Saturn's resonances shifted like titans wrestling, one more giant world was flung outward, ejected almost entirely from the Sun's grasp, yet tethered by the faintest leash of gravity. That world, denied the warmth of the inner system, would have wandered into exile, orbiting far in the cold dark where no light can reach it. Its very existence would be proof that the solar system was more violent, more tumultuous than we imagined. We are not children of order, but of chaos survived. Other myths, more haunting still, picture the hidden body as an outsider. In the crowded nursery of stars where the sun was born, planets may have traded places between systems like contraband passed in the dark. A wandering giant, stripped from its parent star, drifted long enough to cross the sun's path. Caught in a rare gravitational embrace, it became ours, though never truly belonging. If so, Planet 9 is not only an orphan, but an adoptee, a living memory of another star, carrying within its atmosphere and core the chemistry of alien dust. To discover such a world would be to hold in our hands a piece of another sky, to trace its elements and know the fingerprint of a sun that no longer shines. The most radical myths turn darker still. A primordial black hole, no wider than an apple, could weigh as much as Earth, hiding perfectly in the void. Born in the furnace of the Big Bang, it would predate every star, every galaxy, a fossil of the universe's first instant. To find such a thing orbiting our sun would collapse scales of time and space, uniting cosmology with planetary science. The outer solar system would become a shrine, sheltering an object older than the Milky Way itself. Its presence would confirm that the universe scatters relics like seeds, some of which may germinate not in distant galaxies but in the silence beside us. To contemplate this is to feel the vertigo of infinity at our doorstep. Each scenario is extravagant, but each arises because the evidence demands an explanation. The Kuiper Belt's clustering is not a dream. It is data, persistent across discoveries, resilient to dismissal. Whether planet, rogue, black hole, or collective gravity, something shapes those orbits. The theories are scaffolds, erected around an absence, waiting for the day when observation can choose which to keep. They may all fall, or one may stand. Until then, the scaffolds are as important as the answer, for they show how far human imagination is willing to reach when confronted by mystery. What lingers most is the reminder that discovery is never final. Each generation of astronomers has believed its solar system complete, from the ancients who saw 7 wanderers to the Victorians who welcomed Neptune to the textbooks that settled at 8 planets after Pluto's demotion. Each time, the universe corrected us. Each time, the map was redrawn. Planet 9, whether real or not, is the next correction, the next reminder that knowledge is provisional and humility essential. It teaches us that the universe is not a closed museum, but an open wilderness, forever unfinished, forever beckoning us deeper into the dark. The search for the hidden world is not just a matter of theory and speculation. It is a test of our instruments, our persistence, and our willingness to listen to the faintest whispers in the cosmic noise. Telescopes have become our eyes in this pursuit, but they are eyes trained to see things that move too slowly for the impatient. Subaru continues its long vigil, combing regions of sky predicted by simulations, repeating exposures across months and years so that even the faintest motion can be extracted from the stillness. Each new trans-Neptunian object discovered adds another line to the story, another piece of evidence that something unseen may be shaping the system. The hidden planet, if it exists, is no longer a speculation on paper alone. It is a quarry being stalked through the forest of stars. The Vera C. Rubin Observatory looms as the most powerful tool of all. Its legacy. Survey of space and time will sweep the heavens with such regularity that no slow-moving object of sufficient size can avoid detection. Over 10 years, it will create a film of the night sky, frame by frame from which faint wanderers will reveal themselves through patience. Planet 9, if real, cannot hide from such scrutiny. Rubin will either bring it into sight or force us to admit the anomaly is something else entirely. For scientists, this is not just exciting but sobering, because a definitive answer is within reach. and answers always mean change. Other methods add layers to the pursuit. Gaia, with its exquisite measurements of stellar positions, may catch the subtle tug that an unseen planet exerts on the Sun itself, shifting its galactic trajectory by a fraction of a fraction. Pulsar timing arrays, though designed for gravitational waves, could in principle sense the influence of local masses. Even the possibility of a primordial black hole keeps physicists alert, pushing them to devise searches for microlensing events or faint radiation signatures. The hunt has spread across disciplines, uniting astronomers, cosmologists, and particle physicists in a shared chase after a riddle that refuses to fade. Yet the pursuit is more than machinery. It is a kind of devotion, a commitment to chase the faintest rumor of truth across years and decades. Every dataset pored over, every survey repeated, every simulation refined is part of this devotion. Even the failures are instructive. Each empty field, each absence, narrows the search, corners the shadows, teaches us something new about the outer solar system. Science is not just the moment of discovery. It is the long patience that makes discovery possible. And in that patience, Planet 9 has already changed us, forcing us to push our tools, our methods, our imagination farther than we thought necessary. For humanity, the significance of this pursuit is profound. If the hidden planet is found, it will not just be the addition of another world to the solar system. It will be proof that even in our own cosmic neighborhood, vast secrets remain. It will be a reminder that certainty is always provisional, that maps are always incomplete, that discovery is not something humanity once did, but something we are still doing. And if the planet is not found, the lesson will be no less meaningful. It will teach us that the anomalies we thought demanded a world instead demand a new way of seeing, a new theory, a new humility. Either way, the search honors the oldest impulse of science, the refusal to stop asking. The search spreads outward like ripples, and with it grows the network of instruments tasked with listening for the faintest tremor of an unseen mass. Subaru's patient images, Rubin's sweeping cadence, Gaia's stellar maps. These are not isolated tools, but threads in a net humanity has cast across the sky. Each thread catches a fragment of truth, a distant icy body with a tilted orbit, a statistical cluster that should not exist, a limit on how bright the hidden world can be. Piece by piece, the puzzle sharpens. The quarry remains invisible, yet its shadow is traced in detail more precise than ever before. The closer the science comes to answering, the more urgent the question feels. What are we about to uncover? Even spacecraft at the edges of the solar system have become silent participants. The trajectories of probes like New Horizons and Voyager are scrutinized, every tiny acceleration measured, every deviation compared against models. If a massive planet tugs from afar, its influence may echo even in the paths of these emissaries. Thus far, no clear evidence has emerged. But absence, again, is not erasure. It is constraint, a narrowing of the box in which the hidden world can dwell. The mystery tightens its own noose, confining itself with each new test, each line of data, each unanswered question. What makes this pursuit profound is not just the chance of discovery, but the philosophy that underpins it. Humanity has always searched for completion, for finished maps, for the illusion that the unknown has been conquered. But the possibility of Planet 9 reminds us that the frontier is not a line receding into the distance. It is all around us, woven even into the places we thought familiar. The solar system itself is a frontier still, a wilderness that refuses to be fully tamed. Telescopes are not just machines. They are extensions of our humility, acknowledgments that the darkness still holds more than our eyes admit. To build them, to point them, to analyze their findings is to confess. We do not yet know. And that confession is the truest beginning of science. The tools are sharpening, the patience is growing, the data is swelling. At some point, the silence will break. A faint dot will emerge, crawling across seasons of images, a signature too deliberate to ignore. Or it will not, and in that absence, we will be forced to rethink every assumption. Either outcome carries weight. Either outcome expands knowledge. For the hidden world is not only about itself. It is about us, about how far we are willing to reach into the dark, how much faith we place in reason, how deeply we hunger for the unseen. In the act of searching, we already stand changed. The search for the hidden world is a story of endurance, and the instruments we build are as much monuments to patience as they are machines of discovery. Every exposure by Subaru, every simulated orbit tested by computers, every star position logged by Gaia is part of a cathedral of data rising slowly toward revelation. Astronomers know they may not be the ones to see the answer. Years of effort may serve only as foundations upon which others will stand. Yet this is the essence of science. To labor in the half-light, to trust that persistence will eventually coax truth into view. What sets the hunt for Planet 9 apart is its intimacy. This is not an exoplanet circling a distant star, unreachable except by inference. This is here, within our own sun's reach, orbiting the same source of light that nurtures Earth. To imagine it is to imagine a neighbor we have somehow overlooked, a member of the family living quietly in the attic while we explored the universe outside. The possibility unsettles because it collapses the distance between the unknown and the familiar. The mystery is not far away. It is home. Our own solar system is the frontier we thought we had finished charting, now revealed to be unfinished, still alive with secrets. The effort to reveal it carries symbolism beyond science. Each telescope pointed outward is also pointed inward, toward our hunger for answers, our refusal to accept closure where questions linger. Theories and instruments together form a dialogue between imagination and evidence, each testing the other, each restraining the other from drifting into fantasy or despair. Even if the planet is never found, the attempt leaves us altered. We have built better eyes, sharpened our methods, refined our humility. We have been reminded that discovery is not about finality, but about the willingness to search. Somewhere in the darkness, perhaps the world waits, dim and cold, patient as centuries. Or perhaps not. Perhaps the alignment of icy orbits is an illusion, a trick of sampling, a lesson in humility rather than grandeur. But even if that is the case, the pursuit has revealed something larger. The solar system is not an artifact placed in glass for us to admire. It is a living structure, shifting and complex, demanding attention. The hunt for Planet 9 is not simply about adding a planet. It is about rediscovering wonder in the places we thought we had exhausted. The sky is not done with us yet. What does it mean if the solar system still holds a giant we have not seen? The question is more than astronomical. It is existential. For centuries, humanity has strived to complete the map of home, to know every companion of the sun, to place every wanderer in order. And yet the suspicion of a hidden planet lingers like a shadow across that certainty. It reminds us that knowledge is provisional, that even the familiar can betray its incompleteness. The hidden world is a scientific puzzle, but it is also a mirror held up to our desire for closure, our hunger to believe we have reached the edge when in truth the edge forever retreats. If discovered, Planet 9 would be more than a point of light catalogued and named. It would be an event of philosophy. It would confirm that even here, even in the small shell of space where life arose, we are still learning what surrounds us. It would force us to see the solar system not as finished architecture, but as wilderness. The planet's long orbit, taking tens of thousands of years to complete, would stretch our sense of time, showing us that human history is but a flicker compared to a single year of its seasons. To meet such a neighbor is to confront our scale, to be reminded that the rhythms of humanity are not the rhythms of the cosmos. It would humble us, but in that humility lies wonder. And if it is never found? If the alignments dissolve under deeper surveys, if the phantom turns out to be a mirage of statistics? Even then, the mystery would not be wasted. For the search itself has pushed our instruments to new frontiers, has trained our eyes to see more faintly, more patiently than before. It has forced us to admit bias, to refine our science, to temper imagination with rigor. The absence of Planet 9 would still be discovery, for it would teach us that even anomalies can deceive, and that the discipline of questioning is as vital as the joy of finding. Either way, the solar system emerges larger, not because of what we add, but because of how deeply we have dared to look. The philosophical weight of the hidden world rests not in its confirmation or denial, but in the posture it demands from us. It asks us to stand in awe of uncertainty, and to treat the darkness not as emptiness, but as possibility. It asks us to embrace that we do not yet know, and perhaps never fully will. Einstein spoke of the mysterious as the most beautiful experience, the seed of true art and science alike. The search for Planet 9 is such a mystery, part data, part imagination, part silence. To pursue it is to practice wonder, to train ourselves in the art of not knowing and still reaching. For whether there is a planet circling unseen or not, the night sky has already whispered its lesson. Mystery endures, and so must we. The possibility of a hidden world has already transformed our relationship to the cosmos. We no longer look at the outer solar system as an afterthought, a cold and static graveyard of ice. We see it now as an active frontier, a place where mysteries shape the orbits of distant objects and where our assumptions unravel. Even if Planet 9 is never revealed, its ghost has changed astronomy. It has forced us to build sharper instruments, to collect vaster datasets, to interrogate every orbit with suspicion. In this way, the unseen planet is already real, not as a body of rock and ice, but as a force that has shifted human curiosity and redirected the gaze of our machines toward the edge of the sun's dominion. If the planet exists, then it carries with it the promise of discovery on a scale both scientific and poetic. Its surface would be a realm of eternal twilight, sunlight dimmer than a moonlit night on Earth, its sky thick with stars brighter than ever seen from our world. Seasons would last millennia. Storms, if they exist, would unfold with glacial patience, their winds carving landscapes over spans longer than human civilizations endure. To stand there, even in imagination, is to feel the vertigo of time itself, to sense how small human life is compared to the rhythms of the cosmos. Such a vision is not merely science. It is philosophy painted in the colors of astronomy. But even if it is illusion, the lesson remains profound. The solar system does not promise us closure. Each time we think the map is finished, another anomaly opens a new chapter. This is the rhythm of discovery, the humbling beat of science against the silence of space. We are reminded that final answers are mirages, that certainty is only temporary, and that wonder grows precisely where the unknown resists explanation. In this sense, Planet 9 is already a gift. It has restored to us the feeling that the cosmos is not exhausted, that the frontier is not closed, that mystery still lives in the place we call home. To imagine the solar system as complete was always an illusion, but a comforting one. 8 planets neatly arrayed, their motions predictable, their paths eternal. Such symmetry fed our desire for order. Yet the suspicion of a hidden planet breaks that symmetry, reminding us that nature is not obliged to honor our craving for closure. Whether it exists or not, Planet 9 has already altered the story. It has turned the outskirts of the solar system from a boundary into a threshold, from a line we thought finished into a doorway we have only just begun to open. That transformation is not only scientific, it is human. It shows us that knowledge is not the end of wonder, but its beginning. The deeper lesson lies in humility. We gaze across billions of light years, catching the faintest flicker of galaxies long dead, and yet we may have overlooked a world orbiting our own star. This contradiction humbles us, but it also ennobles us. It proves that discovery is not a relic of the past, not something confined to ancient astronomers or the age of voyages, but an active calling. The universe has not finished surprising us. It still waits with secrets close to home, secrets large enough to sculpt orbits, to tilt planes, to whisper through the architecture of the solar system itself. To search for Planet 9 is to stand in continuity with every human who ever looked up and asked, "What else?" And so we end where we began, in mystery. A world may circle our sun, vast and unseen, patient as centuries, writing its influence into the ice and silence beyond Neptune. Or it may not, and the mystery may dissolve into new explanations we have yet to imagine. Either way, the meaning is clear. The solar system is unfinished, and so are we. The hidden planet is a symbol of that unfinishedness, a reminder that the cosmos is deeper than our maps, richer than our categories, stranger than our dreams. It whispers to us from the dark. Not everything has been found, not everything has been named. And as long as that is true, wonder will endure.